let's go back. Compound probability. There's different types of compound probability. You wrote down three terms that deal with it. The first one talks about independent events. If the outcome A does not affect the outcome B, right? And there's that formula. So here's an example which will help it seem a little bit better. That goes with independent events. The probability of getting heads and getting a 6 on a die. Okay, like a little dice, or you say die for singular, right? Okay, so, well, flipping a coin, that's not going to affect what I roll on the die, right? So that's how, right there, what that means. A does not affect B. So, what is the probability of getting heads and getting a 6? Write that down, guys. Come on. Well, what's the probability of being a head? That's what you did in section 1. Week 1. 1 out of 2, right? And then what's the probability of rolling a 6? 1 out of 6. So what you do with that formula, you multiply them. So 1 times 1 is 1, and then 2 times 6 is 12. So the probability of getting flipping a head and rolling a 6 is 1 out of 12 times. Okay? Make sure you write the example down. Okay, so dependent events. This is without replacement. Okay? Still multiplication in the formula, assuming that A occurred. Event A. So here's the example here. So you're working with like maybe pulling from a bag of marbles or dealing with a deck of cards. So of a 52 deck of cards, what's the probability of pulling a king and then another king? Okay? Pulling a king and then another king. So for now replacement, think about it. Have y'all ever played poker before? No. You ever some sort of card game? Well, you get dealt the cards, right? Well, they don't deal you the cards and then they put it back in and you go for the other person, right? Once you get that card, it's out of the deck and it's no longer a probability to get anymore. Okay? So here, you got a deck of 52 cards. How many kings are there, y'all? 4. So what's the probability of drawing a king? 4 out of 52. Okay? Then drawing another king. Well, you got that king already. How many kings are left? How many total cards? It means 1. So getting a king and then another king right after that. 3 out of 51, 4 out of 52. You multiply that. It'll end up reducing to 1 out of 221. Okay, it's 12 over whatever 52 times 51 is. So 1 out of 221 chances. So you see how hard it is to gamble. You go over there to Vegas, you get all 3 for 21. How to just get 2 kings right off the bat. That's not a high chance. What is the percent, y'all? Look at your calculator. I got it. 0.004. Okay, so 0.45. Okay, so to get percent, you move it over twice. So that's 0.45%. That's not even 1%. Okay, so you see how Las Vegas is real rich and they take a lot of people's money? Look at the probability of doing that. Okay, in the pair of kings right off the bat. First 2 cards. Okay. Now, of course, you get 5 cards in poker, right? So you still have, like, I guess, 3 cards. Or if you're playing all of them, you get 7, right? 2 from there, and then twice, so kind of like 7 total. That's a 0 point. Anyway. Okay. The next one is called overlapping. It's like when you have overlapping sets, are those that have some elements in common. Okay? Hopefully you wrote the formula down. Probability of A plus the probability of B minus the probability of A and B. So here's an example of overlapping. Okay. Rolling an odd number and rolling a number higher than 4 on a 6-sided die. So a regular 6-sided die. Okay, or cube, whatever you want to call it. You roll an odd number and you roll a number higher than 4. Okay, well, how many odd numbers are there on a die? 3. There's 3 odd numbers. Okay, 1, 3 out of 6. Following the formula, our second event is what? Rolling a what? A number higher than 4. How many numbers are higher than 4? 2, 5, and 6. So A and B, you're going to add those, but then now you're going to subtract anything that's in common. Are there any numbers higher than 4 that are also odd? The 5, right? So you want to subtract that. Okay, and that's just the formula of overlapping events. So anytime you see something that will be in common like that are all like on this case, odd and higher than 4, that's what goes there. A and B, so both together. So then addition and subtraction of fractions, they all have the same common denominator, so you don't have to mess with that. So 5 over 6 minus 1 over 6 is 4 over 6, which that reduces to what, y'all? Okay, so that's overlapping. The next one is it's a compound event that is mutually exclusive. A compound event that's mutually exclusive. So here's the definition. When 2 or more events cannot occur at the same time. When 2 or more events cannot occur at the same time. So probability A B, A plus B. Here's an example of that one. Probability of rolling a 4 or 8 on a 10-sided die. If I roll the die, can 4 and 8 pop up on the same roll? No. So that's why it means that it cannot occur at the same time. Okay? So how many 4s are there on a 10-sided die? 1 out of 10. So 1 out of 10. That's the event A, the 4. How many 8s are there? 1 out of 10. So you add those two together. So this is mutually exclusive, meaning it can't happen at once. Okay? Over there, kind of did, right? If you were able to roll an odd number that is higher than 4, that's when you have to use that subtraction formula. Okay? All right. Make sure you have the formula. Okay, and then compound events that are inclusive. This is kind of like the opposite of that. So what do you think that is, y'all? Yes. When events can occur at the same time. When events can occur at the same time. So notice the formula that we're using again. The minus the probability of A or B, which is A plus B, probability of A plus the probability of B, minus the probability of A and B. So last example, there is going kind of with the some sort of like numbers. Rolling in odd number, not in. Rolling in odd or prime number. So rolling an odd number or prime number on a 10-sided die. Rolling an odd number or prime number all right. So event A, odd numbers. How many odd numbers are on a 10-sided die? 5. So that's what goes first. 5 out of 10. Event B, how many prime numbers are there? That'll look up right here. How many prime numbers are there? I know you see the number, but be sure in your head. Is one a prime number? No. We can use that one. Is two? Okay. Is three? Is 4? 5? 6? 7? 8? 9? And 10. So 4. See how there's 4? So 4 prime numbers out of 10. Okay? Now, here's where you want to kind of think of the overlapping and what they have in common, mean the same kind of mean the same thing. So, how many are odd and prime? Out of those 4, how many are one of them are odd and prime? So is 2 odd and prime? Is 3? Is 5? Is 7? So there's 3. All right. So 5 plus 4 is 9 minus 3. 6. So 6 out of 10, which reduces to what? What? Because an A and B are 2 different events. So we're talking about odd and prime numbers there. Over here we're talking about 4 and 1 and 8 there. When events can occur at the same time and they can't occur at the same time. Because they're dealing with 2 different things here. I know what you kind of mean. That's just the way probability is. They have race go with more in between. Okay. All right, let's fill out that table now that you have on your thing. Okay. Let's fill out that table now. You should have been writing on that. I don't know why y'all were writing on that. You should have been writing on your paper. Yeah, I told you you're gonna write on your own paper that we're dealing with that second. Okay. Take a listen. All right. So now, compound events. Alright, so compound events, we just went over that. Also known as what? Also known as what? Starts with an I. Inclusive, so maybe add that in parentheses. Okay. So a compound event is an event that is made up of 2 or more events. It's a different way to say it. Okay. It's like get a heads in a coin toss and a 3 in a row of fair number 2. When they say fair, you hear that on your assignment. Okay, fair just means it's not rigged, like heavier on one side. It's not got double 2s. It's just 1, 2, 3. It's like a regular standard time. Okay. So what was the formula for that one? Do you remember that? By the way, I'm gonna check with the other teachers to see if y'all have to memorize the formulas or not. Okay. So what's the formula for that one? Is that the one with the minus? Or is it the one without? It is with. Very good. Okay? So I'm going to try to remember that. Okay? All right. Independent events. Okay? If the occurrence of an event does not affect how another event occurs. Okay? That's known as independent. Choosing a green apple from a bowl of fruit, then put the apple back in the bowl. And you choose an orange from it. Okay, so like the deck of cards where you put the card back, or maybe draw them from a bag of marbles with different colors, you put it back. So which one is this formula? Is it with the minus or not? Addition or multiplication? Multiplication. Okay? Which is a good way to memorize this. Independent and dependent events are both what? Multiplication. Okay, so that should quickly take you to that formula there. This this one again is the occurrence of an event does affect how another event occurs, and the events are called dependent. And it's still multiplication here. Choose a red marble from a bag. Do not replace it back. Okay, so that's kind of the big thing here. You can replace here, do not replace it over here. Okay. Mutually exclusive events. Okay, compound events that are mutually exclusive. Events that cannot happen at the same time are called mutually exclusive. So does this until the minus? No. Okay. You want to kind of remember the minus means that you kind of have, you can get double with something, I guess, so to speak. Like this one you can't, because it cannot happen at the same time. Okay? And then the last thing, overlapping events, kind of the opposite of that. So does this one have the minus in it? Okay. All right. There's that. Okay, and then the last set of examples, after we leave, I'll try and guess which one of those is going to, what kind of probability that goes with this. Okay, so you draw the jack of spades, you keep it, then you draw a queen of diamonds. So if you're keeping it, you're not what? You're not putting it back in there, so which one is that now? Dependent or independent? Okay. And then just to kind of refresh, I have to do paper. Which formula is that? Minus the multiplication, which is also the same as what? Independent. So independent is multiplication. Okay, next one, number 2. You draw one card and you get a king or a club. King or a club. Thank you. I'm glad somebody kind of saw that. Because this is 2 that can happen at once, right? Isn't there a club of kings? So which one do you think that feels like? Overlapping maybe? Or what's the other one? Compound. Yeah, compound. Okay. This one is overlapping because you can get them both at the same time. Okay, because there is a king of clubs. The third one, you draw 2 cards and you get the 2 of hearts and the 3 of hearts. You draw 2 cards, you get the 2 of hearts and the 3 of hearts. Anybody guess? Anybody? Compound, compound, even, or inclusive. Or draw 1 card and get a queen or an ace. So as I did the last one, you draw 10 of hearts, you replace it,